Okay, so 17b. Excuse me. The first thing we're going to talk about is the multiplication property of -1, essentially. Do you remember what happens if I take a -1 and I multiply it by something? It becomes the opposite of whatever we multiplied by, right? So if I do -1 times x, I get a negative x, okay? If I do a -1 times a negative x, I get a positive x, right? -1 times a negative x, now it's going to be positive. So when you multiply something by a -1, everything becomes the opposite of what it was, okay? So that means if I have something like this, okay, there's no number out in front behind the negative, but there is a number there, essentially. Anybody know what number should be there?
1.
A 1, okay? So that negative out in front is acting right now as a -1. Well, now, if I'm going to distribute that, what it's going to do, just like what I said up here, it's going to change everything to the opposite of what it was. So -1 times x is what? A negative x, okay? And then it's -1 times 6, but we're also subtracting. So I usually just think of it as a -6 times a -1 is a positive 6. So we say plus 6, okay? Now, if you don't like to do it that way, that's okay. You can do it this way instead. -1 times x minus, and then -1 times 6 is a -6. And then that you would simplify, minus a negative is plus a positive. So it's still going to be a -x plus 6. So regardless of how you think of it, you should still get the same answer as everybody else, okay? So just remember, when you distribute a negative, that negative is going to make everything opposite of what it was. If it was negative, it's now going to be positive. If it was positive, it's now going to be negative, okay? Do this one for me. Oh, my stylus is falling to pieces, guys. This is not good. Okay, first one, we're going to do the opposite of 2y minus 3x. Okay, take a second, more than a second, take a minute, and see what. All right, what do you get? -2y. Okay, so this was positive, now it becomes negative, and then that -1 times a -3 is a positive 3x. Okay, you make it opposite of what it was. Okay? All right, do another one. What if it's a negative a plus 5? What's that going to become? This will be, right, negative a, and then a -5. So plus a -5, or you can just call that minus 5, okay? Technically, this is the same thing, plus a -5, but I feel like people get a lot more confused when they start putting parentheses in to show something's negative, and I would just go with that top one, okay? All right, what will this one be? The opposite of 6m minus 9n. What does that become? Right. Plus 9n, yep. So negative 6m, and then minus a negative 9n would be plus 9n. Okay, any questions on those? No. So just pay attention if there's a negative out in front. Don't forget to distribute that negative. Even though it doesn't look like there's a number there, it's a -1, right? You're just multiplying everything by -1. Okay, now we get into some vocab. Really, these are just things you need to understand what they are so that when I'm referring to them, you know what I'm talking about. So the first thing is a term. Okay, when I talk about which term in the expression or which term in the equation, a term is a number, variable. What's a variable? a letter, right? X, A, B, those are all variables. Or the product of both. What is a product? Multiplication. So basically what they're saying is a term is a number, a variable, or take a number and a variable and multiply them together. That's considered a term also. So some examples of terms. The number 5 is a term, right? It can just be a number. The letter Y. This is that's a semicolon, sorry. It looks like a J, huh? We'll just do a comma. The letter Y. That's a variable. That is a term in an expression, okay? Or I could do 2xy. That would be a term because I'm multiplying a number and a variable and a variable. Okay, so those are all terms. One of your terms is going to be called a constant. There's not always a constant, but often there's a constant. And the constant is the number that has no variable. And if you think about the name of it, it makes sense. If something is constant, it's never changing, right? Well, the number 7, for instance, if I'm adding 7, it's never going to change to adding 11. A 7 is always a 7, okay? So 7 would be a constant, or 11 would be a constant. Any number that doesn't have a variable behind it is a constant, okay? Another term, coefficient. Does anyone know what a coefficient is? You've probably all heard it, right? But it's not one that tends to stick if you haven't used it a lot. A coefficient is basically the number that comes before a variable. So it's the number that comes before a variable. Okay, so for instance, if I have 2z, okay, my coefficient right now is the 2. It's the number that comes in front of it. Or if I have 3xy, my coefficient is what? The 3. Okay, so it's always a number that comes right before a variable. So whatever you're multiplying your variable by, that's your coefficient. Okay? Okay, so here's what I'm going to do. I'm going to write a big expression for you, and we're going to talk terms and constants and coefficients and the terminology that we have here. So let's say I have 6a squared minus 5ab plus 3b minus 12. Okay? You could convert this so that everything is addition, and it will help you to see a little more what is positive and what is negative. But what I want you to get in the habit of is not necessarily having to do that, okay? So you could call it this. You don't necessarily need to write this down. You're welcome to if you want, but I'm going to use the blue one. I just want you to see what you could do if this makes more sense to you. So if I'm saying minus 5ab, that's the same as saying plus a negative 5ab plus 3b plus a negative 12, okay? By the end of this course, you should be familiar enough with this that you don't have to do this. If you want to break it down right now to help you see it better, that's fine. But by the time you get done with Algebra 1A, you shouldn't have to, okay? So if you want to try without doing that, go for it. Here's what I want to know from you, okay? In this setup, what are your coefficients? 6 is a coefficient. Okay, is it 5? It's negative 5, right? Because essentially what you're doing is plus a negative 5. So just make sure whatever sign, so plus minus comes before the number, you're thinking of that number as the positive or negative, whatever the sign is. okay? So this is technically gonna be a -5 for our coefficient. This is a 6 for our coefficient. What's the coefficient here?
3.
Right, and it's positive, okay, so just 3 is our coefficient. So all of these are coefficients. Is -12 a coefficient? Why? It doesn't have a variable, okay? So what is -12? That's a constant, okay? So this -12, it is a term. It's also a term. It is a constant term, so that will be our constant, okay? Okay, now let's talk terms. How many terms do you see here? I'm just gonna rewrite it because I have scribbles all over the place. I don't want to throw you off. So 6a squared minus 5ab plus 3b minus 12. How many terms are there? Nope. It's 4, right. So this is a term, and this is a term, and this is a term, and this is a term, okay? So all of these are terms. So you have 4 terms right now. Okay? Questions on that? Okay, so with terms, we have what are called like terms, and I almost guarantee that you've all heard of like terms before. Does that sound familiar?
Yeah.
Yeah? Okay. Yeah, what is it? Tell me what it is.
Well, if you have a problem that has 4a and then like plus 2 and then plus like 2a, then it would be the like terms are 4a and 2a.
Right. So you're looking for terms, right? The different pieces of our expression or of our equation, terms that have the same variable factors. So like terms have the same variable factors. In other words, the variables that come behind our numbers are identical, right? So like terms would be if I said 8x squared plus 11x squared. We would say those are like terms because they both have an x squared, right? So you're allowed to add those together. When they are not like terms is, well, let's do another one. Let's say I have 3ab minus 6ab, right? Those ab's are identical. Those are like terms, okay? Where they're not like terms, yes?
Oh no, I was going that.
Oh, okay. Where they're not like terms is if I say 8x plus 11x squared. This is different than that. Those are not like terms. Okay, you can't have a squared and just an x by itself. X and x squared are very different things. So make sure you pay attention to the exponents too. The exponents have to match up, but also the variables have to match up. Okay? Questions on that? Yeah.
So like for the problem that we're doing right now, the negative like 5ab is not the same as 3b, right?
Right.
So, like, okay.
Yeah, so this 3b and this negative 5ab are not like terms because the ab and the b are not identical. Yeah, good observation. Yeah.
Would it be like, if it's not like terms, would it be like a different answer or?
You just can't bring it together. Like if you have like terms, you can simplify farther. If you don't have like terms, then it just stays the separate terms. So you just can't go as simple with it. Here's another one that you could maybe get confused on. X squared y and xy squared. Those are not the same, right? One, the y is squared. One, the x is squared. Will you stop tapping your pen? Thank you. So these are different, okay? That means those are not like terms. Does that make sense?
Yeah.
Okay. Let's do a little bit of simplifying with like terms then. All right, second example here. They're going to tell you to simplify from this. So 8x squared plus 2x squared. The properties we learned at the very beginning of the chapter apply here. That's where those properties come from. So essentially what we're doing is the reverse of the distributive property, because we're gonna take our 8 and our 2 and add those together and then attach the x squared to it. Okay, so when we simplify this, 8 plus 2 is 10, and then we attach the x squared. The other way I tell people sometimes to think about it is give your variable a name. Give it an object. So apples, okay? If x squared is apples, I'm saying 8 apples plus 2 apples is what? 10 apples, right? So my apples has to stay the same. You're not gonna make x squared plus x squared become x to the 4th. That's not the same thing. We're saying we have 8 x squareds and 2 x squareds, and we wanna add those x squareds together, so there are going to be 10 x squareds. Does that make sense? Yeah,
What if there's like a subtraction?
we'll do that too. Yep, let's do that right now. All right, so let's say you have 5y minus 3y. Okay? So essentially what you're doing is 5 minus 3 and attaching your variable to that. So what would that be? That would be 2y. Okay? What if it was 8y minus 11y? What would that be? Not 3y, negative 3y, right? So 8 minus 11, and then attach your y. Well, 8 minus 11 is a negative 3, so that would be negative 3y. Okay? All right, let's get a little fancier here. Let's see if you can pick out like terms. 5x minus 3 minus 3x plus 6y plus 4. If you want to rearrange the problem so your like terms are next to each other, you can do that. What would your like terms be right now? 5x. Okay, now here's the thing. Who was just telling me that? Serena. Selena? Serena. All of a sudden I second guessed myself. 5x, and she said minus 3x. Now here's where a lot of you are going to go wrong. It is minus 3x. You need to keep the sign that's in front of the number, not the one that's behind. So sometimes people see like, let me give you a different for instance here. Let's say it was 5x plus 3 minus 3x. Sometimes people see this and they go, it's 5x plus 3x. It's not the sign behind the number, it's the sign right in front of the number that you need to use. So don't use this one, use that one. Okay, so Serena had it, 5x minus 3x. So if you want to rewrite it, you can rewrite it like this. Plus 6y, and that's the only y there is. And then what are your other two numbers going to do? Minus 3, right? What's in front of the 3, and then plus 4. Okay, so if we simplify this, 5x minus 3x is what? 2x. Oops, I put a y, it's an x. 2x, then what? Plus 6y. There's nothing you can do with the y. That's the only y there is. Then what? Be careful here. It's plus 1, right? So it's minus 3 plus 4. So negative 3 plus 4 is not 7, right? You have to keep the sign in front of the number. So negative 3 plus 4 would be plus 1. So this is as simple as you can go. Okay? Hey, girls. Are you with me back there? Taking pictures?
No.
Okay. Take notes or put that away. This part of it is where I often see mistakes, just in breaking down which variables have to stick together. So just make sure once you get to a point of 2x and 6y and 1, are there like terms? No. So you're done. Okay? Don't try to simplify that farther. Don't tell me it's 9xy. Okay? You can't add them together if they're not identical. All right? You good on that? Okay. How about this one? We have 4 more of these and then we're done. 3y minus y. What would that be? 2y, right? That minus y is a minus 1y. So you're going 3 minus 1 and attaching the y. So that would be 2y. Okay? How about this one? Did I skip a letter? Oh, no. Oh, because I added an extra one in. That's right. Okay, how about if it's negative 7m, n to the 4th minus 5m n to the 4th. Are those like terms?
Yes.
Yes. Okay. So we're doing negative 7 minus 5. What is that? Negative 12, right? Negative 7 minus 5. So it's like a negative 7 plus a negative 5, or you can just do negative 7 minus 5. So that would be a negative 12. And then it's m n to the 4th. Okay? How about this one? 8x squared minus 2x to the 4th minus 2x plus 2 plus xy. None of them are like terms. So your simplest answer right now is this. There's nothing you can do to it. Okay?
Oh, that's the answer.
That's it. You can't combine anything because none of them are the same in terms of like terms.
So if that was like on a test, you just leave it.
You would leave it. You'd put a box around it.
What the?
Yes. Okay, I'm going to do one more. And then we'll be done. 3x minus 4y squared plus 7 minus 5x minus 6y squared plus 11. A lot of like terms. Anything match up with my 3x here?
Negative 5.
Yes, minus 5x. Okay, so if you want to rewrite it, you may. 3x minus 5x, so they're next to each other. We'll simplify that in a minute. What else? What other like terms? Okay, negative, right? So minus 4y squared minus 6y squared. Okay, then what?
7 plus 11.
Plus 7, right? Plus 7 plus 11. Okay, now if we simplify, this is what?
Negative 2.
Negative 2x. What's that? Minus 10y squared, right? Negative 4 and negative 6. Don't forget that minus out in front of the 4. Then what?
Plus 18.
Plus 18. Okay. Now what? You're done. Okay. Don't take it any further. So many times people want to go, oh, so negative 2 minus 10 plus 18 is, and you can't do that. You can only combine it if they are like terms. So you're done right there. Okay? Only combine if they share variables. All right. That is it.